Hello everyone, and welcome to a brand new episode of Block Talk, where we talk about everything related to Azure and blockchain all up. My name is Ziad Rajabi. I'm a program manager on the blockchain team.
And I'm Cody Bourne. I'm a software engineer on the Azure blockchain team.
In today's episode, we want to give you guys a deep dive on an Ethereum blockchain solution we've created on Azure. Specifically, we want to talk about two different solutions so you guys can get an idea of how Ethereum works on Azure. One is a proof of work, and the other one is a proof of authority. And we're going to give you guys a demo on the proof of authority solution on Azure. So when you look at Azure all up and you go explore the platform and you go to the actual marketplace, you'll notice there are quite a few solutions. I don't even know how many solutions we have available now.
Yeah.
It's been going on for several years. We, as Microsoft, publish our own first-party solutions, whether they are Hyperledger Fabric, Ethereum, Corda, or whatever it may be, and we have third parties also publishing as well. And so you're going to see quite a long list of different solutions out there. And really the intention there is that you as a customer can use whatever ledger you want in whatever way you want to use it. Whether you want to use it as a simple dev test environment, whether you want to use it as a single environment for only you, or whether you want a multi-member environment for you and other members in your consortium. But in today's session, we're going to cover Ethereum, and we're going to specifically cover proof of authority, show you how that solution works since it's the latest one that we've created.
So before we go into proof of authority and why we think it makes sense for enterprises, we first want to look at proof of work and kind of justify the role that it plays within the blockchain. So in order to do that, let's take a look at Sybil attacks, a potential attack on the network. So a Sybil attack is where you have some identity that's representative of a certain user, but you're not able to be sure whether that identity maps one-to-one with your users. So here's a classic example of this. So back in 2016, there was a $200 million Antarctic research vessel that was built, and they had the terrible idea of crowdsourcing the name. So they created an online poll and allowed people to vote on what they thought the name should be of this vessel. And of course, they ended up with some ridiculous names, such as Boaty, McBoatface. And unfortunately, they didn't actually go with this name, but they did name the submarine on board this wonderful name. And this just kind of demonstrates what the problem is when you just open up any kind of system to the public on the internet. And this arises because there's no real cost of interaction for the users. So if I do want to attack the network, I don't really have to pay any cost. I don't put anything at risk. So what we want to do is to solve this problem is just essentially increase the cost of attacking. So there are a variety of different ways to increase costs. So in traditional systems, we looked at providing some kind of identity or reputation system behind each of these accounts or actions that are going on in a system. But you can also look at potentially using legal action as a way to prevent attacks across corporations. Now with blockchain, we saw this innovation, which was to use electricity or cryptocurrency as a form of Sybil attack prevention. So if I wanted to spam blocks on the network, I have to burn some amount of electricity, and this is something that we associate with proof of work. Or if I wanted to spam the transactions on the network, I have to pay some fee in cryptocurrency. And cryptocurrency can also be used as a form of stake. So the interesting thing is we can break these four types into two buckets. One, the top two require some identity, and the bottom two can be done in completely anonymous systems. So let's look at proof of work. So proof of work, obviously, it could be subject to Sybil attacks. So there's two types of attacks. One is consuming blocks, being able to create blocks and spam blocks on the network. And the second one is to be able to spam transactions on the network. So as we mentioned, proof of work solves block generation spam by forcing each of the block creators to pay some fee in terms of electricity. The transaction spam is solved using cryptocurrency fees. Proof of work also ensures fairness on the network. So proof of work is a random algorithm, meaning that when your computer is doing this work, it will randomly find a solution to the proof of work problem, and that solution will provide it the ability to generate a block. And this is done based on this algorithm, so it's completely fair, it's random, but it's also asynchronous, so two people can be creating blocks on the network. That means that you need to actually slow the network down a little bit, because if too many people are creating blocks at the same time, you will end up with different histories, and the blockchain will diverge. This is something that we call a fork. And then finally, proof of work provides a mechanism to agree on the state of the blockchain. So if you have any kind of disagreement, then you can look to whichever blockchain has the most work that's been done on that in order to decide which one is the correct, which one is the canonical blockchain.
I think a couple of things to note about this proof of work algorithm and the way that they prevent the Sybil attack is that, number one, this is what's being used in today's world with Bitcoin. It's being used in the world of Ethereum Proof of Work, the public Ethereum network. And some of you who are new to blockchain may have heard the term miners. Do you want to explain how miners and mining play in this whole space?
Sure. So miner is just a machine that you've set up to solve these proof of work problems. And every time you solve the problem, you get the ability to create a block on the blockchain, and you get rewarded fee in cryptocurrency, and that's how cryptocurrency is distributed out to the public. But you also, the goal is to get more money in return than you've spent. So if you create a block and that block has a bunch of invalid transactions in it, you've burnt all this electricity, but you won't have received any cryptocurrency in return. So it's in your best interest to not actually attack the network. So proof of work actually provides security on the network. So it's really good for like anonymous networks where you don't really have an identity behind them. However, with enterprises, that's typically not the case. Each of these enterprises has built up a reputation over time. They have a legal framework that they follow. So anonymous is really good for these public open networks, but for enterprises, they can leverage this identity to kind of like work on their behalf. So let's take a look at proof of authority. So it uses this identity as a form of Sybil attack prevention. So if you attack the network, I know who you are. I can just kick you out of the network, or I can decrease your reputation. It's fair, so we can simply take turns creating blocks. Because I know each of the actors on the network, we can take turns, and we have our own designated time period to create a block. As a result, because it's synchronous, we can actually speed the network up. So the public Ethereum network, as an example, uses proof of work. It has around 12 transactions per second because it wants to prevent all of those forks on the network. With proof of authority, we can actually speed it up a lot more, and you're only bound by the hardware and the network that you've deployed to. And so we've seen on an average around 400 transactions per second, peaking up to even 2,000 transactions per second. And finally, proof of authority provides consensus, so the ability to know which chain is canonical, and that's simply it's based on who has signed off on each of these blocks. And once you have enough signatures on a block, it becomes finalized. It can never be reverted. All right, now we're going to walk through a demo of how to deploy an Ethereum Proof of Authority network in Azure. So first, you'll go to your Azure portal, and you'll say, I want to create a new resource. You'll select the blockchain category, and you'll see that here, as Ian mentioned, we have a variety of different ledger solutions that you can deploy. And in later talks, we'll probably go through in depth more of these different ledger solutions and how to set them up. But for now, we're going to select Ethereum Proof of Authority. Now, I've already filled out this form here, so you don't have to watch me fill it out, but we'll walk through what each of these fields are. So the first thing that you'll look at is if you wanted to create a new network or if you wanted to join an existing network. And so depending on which one you select, we will automatically populate the rest of the form to make it easy to join an existing network.
Yeah, the join existing really is for when you want to create a multi-member solution across a consortium. If you're still in the proof of concept phase or initial pilot phase, you may not need to do that. You may just be okay with just a single member deployment.
Yeah, but so regardless, even if you are setting up a multi-member deployment, the first member has to say, I want to create a new network. And they will then provide information to the other members so that they can set up the rest of the network. So you'll provide your email address. This is optional if you wanted to receive a post-deployment email letting you know that your deployment is completed. It takes around 10 minutes to deploy, so it's kind of nice, so you don't have to wait. You can specify your VM username and password so that if you wanted to SSH onto the machine, you can do that. And then you can specify your subscription name, your resource group, and the location that it's in. Then the next blade we're going to look at, I'm just going to zoom in a little bit so it makes it easier to see. So the next blade is you can specify how many regions you want to deploy to. So this is nice for high availability scenarios, but maybe you're deploying a test environment, proof of concept, you only want one region or a couple machines. That lowers your cost. You don't need that high availability, but when you're ready to go to production, you want to make sure that your nodes going down is not going to affect the network. So we offer the ability to deploy to up to 5 regions. And this is on a per member basis. So we'll say, okay, I want to deploy to East US and West US. And then you can say how many nodes do you want to be deployed in each region. Each node will be given its own identity, which will allow it to participate in that proof of authority consensus. You can specify the hardware SKU that you want. We've put together a comprehensive guide on how to select these based on the performance that you're looking for. You can check out our docs in order to learn more. So I'm just going to select the recommended one to start with. Okay, and then here are the Ethereum specific settings. So you'll set your member ID. Each member should have a different identifier. 0 based, of course, for the first member because we're not barbarians. You'll specify the Ethereum address. And here, this is something that you can pull from MetaMask or really any kind of Ethereum wallet. This represents your admin account that is going to be used for participating in the governance on the Proof of Authority network. And then we have some advanced options that are allow you to specify whether you want to deploy behind a VPN. It makes it a little bit harder to connect, but it's something that we see is important for a lot of our enterprise scenarios. You can specify the block gas limit and the block reseal time, and you can specify a transaction permission contract. I think it makes sense to go into those in a later talk. Right now, we're just going to look at a very high level of simple deployment. And then you can specify whether you want to set up OMS, Azure Monitor. So for each of the machines, we'll set up agents on those machines. You can track each of the VM health. You can see the blocks that are created on the network. It's basically like a full statistical dashboard for you.
I think my favorite thing about the Azure Monitor piece is you can subscribe to events when things are happening. So let's say your CPU is getting spiked up or your machines are getting just smashed with a lot of performance issues. You can get notifications based on whatever criteria you specify, and you don't have to always monitor it. So I think that's one of the nice features of that particular aspect.
Yeah, and the dashboards that it creates are completely customizable. We build things that we think make sense, but it's really up to you. You can take it and tune it however you want. So after you've deployed this, this will take, like I said, around 10 minutes, and then you'll be given a URL that you can go to that is your governance dashboard URL. So what you'll see here is an existing deployment that I have set up where I'm an admin on this network. And now what we're going to do is show how Ziad can have a deployment and we can join them together and we can both be administrators on the network even though we may be in completely separate organizations.
Do you want to explain a little bit what you mean by a governance dashboard? I think that for people who are new to blockchain may not understand sort of what it is that they're seeing here.
So with traditional systems, maybe you have like an admin that can control everything for a given application. Here, with the blockchain, it makes sense to kind of distribute that power across multiple parties. And we actually use smart contracts that are deployed on the POA network that handle all of this governance. And so governance is about, this specifically is about, determining who has the ability to create blocks on this blockchain. And so we've put together this dashboard to just make that experience easier and more intuitive. So what you're seeing here is my dashboard experience, but that's going to be different than Ziad's dashboard experience, because when we look at Ziad's, actually, let's switch over to your view.
Okay, great. Let's assume that Cody sends me this URL to this particular experience, or this governance experience. I'm not an administrator. Cody is an administrator, as you can see here, listed down here under his alias, but that is his actual address on the Ethereum network. I am not. So for me to become an administrator, I have to nominate myself, or somebody has to nominate me before I can get into that system. So let's just go ahead and do that and show you what this looks like. So I'm going to nominate, and I've pasted my address. This is just who I am on the network. And I'm going to just give you my name. And I'm going to hit nominate. What this is doing now is it's basically creating a transaction that's being pushed in the system. And now all administrators, which in this case is just you, Cody, gets to decide whether or not I can be an administrator or not. And we can see here, if I go to the candidates tab, you can see this is a list of all of the different people who are requesting or who have been nominated to become administrators in this network. And as you can see, I'm 0% of people have voted for me. So Cody, switch over, please vote for me so I can be an administrator with you.
All right. So let's get Ziad on this network. So as you can see, the difference between our views is that now I have the ability to perform this voting action. So I'm going to select his account. Let's say he reached out to me and said, hey Cody, this is my address. You can expect me to be trying to join the network. So I said, okay, I am going to vote him in. And this, again, is going to open a request from MetaMask. And I'm going to sign off on that request. Now you'll notice one thing is that we didn't have to pay any Ether. And the reason is because on Proof of Authority, you're essentially using other mechanisms to prevent Sybil attacks, so we don't have to use this kind of more primitive approach of paying for transaction fees with this Ether that doesn't really have any value on the network. So now you can see that I've voted for Ziad, it's gone through, and because it was just me as an admin on the network, that vote reached a majority, and he became an admin. So now we switch over to this admin page. You'll see that he is an admin, and now at this point we have the same amount of power on the network. So he can go in and add other people, or he can even go in and vote me out if I start misbehaving. So you'll see here I have this validators tab. These are my validator nodes that are participating in consensus. But now Ziad will want to go and add his own validators. So let's take a look at that experience.
So let's switch over here. So this is back to my screen here. You can, again, you see my name up there at Ziad. You'll see that I'm listed here. And I also have the ability to vote against people and rescind my votes. And now, if you have noticed, I have this new tab called Validators. I can go click on that. And what he did is he added me as an administrator to the network. However, I have not added any of my validator nodes, so I'm not participating in consensus. So if I want to participate in consensus, what I do is I have this nice handy button here called Add My Validators. And what that's doing is, if you remember from the deployment experience that Cody showed, I got to specify how many nodes and validator nodes I have in the network. And what this thing is doing is it's pulling those nodes and then adding them to the entire network so that those nodes now are sort of labeled as validators that I can drive now towards consensus. So here are my nodes, those are the addresses of those nodes and the names of those VMs. And you can see sort of how I'm participating in now the network.
And one important thing to note is that even before those nodes became validator nodes, they were still synced with the network, and they were acting as transaction nodes. So someone can go in and start submitting transactions to those, or they can simply use those as an audit log of figuring out what exactly is going on in the network. So there's still value in deploying a proof of authority stamp without becoming an authority. But that authority provides a special privilege of being able to create blocks on the network. But as a result, you have to make sure that those nodes are also highly available, because if you kind of experience any outages, that will take away from the bandwidth on the network.
Yeah, what we showed you today is really just the administrator experience for, again, managing the governance aspects of your consortium. It's a fully working network that you can connect to, perform transactions, and do a bunch of things. And so in next episodes, we'll show you how to actually drive transactions onto this network. Specifically, we'll talk about Workbench and how Workbench makes it easy for you to drive transactions on the system.
Great. And so that's all that we have today. Like I said before, everything that you saw today is deployable in Azure, so check it out in our Azure portal. You can also find it, our documentation for this at aka.ms/Azure Blockchain. And of course, you can follow us on Twitter at MSFT Blockchain, or follow us on YouTube or Channel 9.
Right, and share any comments you have, and we'll definitely take a look at them. Thank you so much, guys.
Thanks.